All right, everybody, welcome back to another AFDA chapter. In this chapter, we're going to do chapter 15, which is talking about something called the normal model. Now, up until this point, really, we've done a lot of algebra. We've started to talk about probability and a little bit of statistics. And in this section, we're really going to talk about what the main section of statistics is, this idea called the normal model. So, what is the normal model? And before we get into what A, B, and C are, because A, B, and C are really going to be kind of all the same thing, let's talk about what happens when you as a class take a test. When you all as a class take a test, the most measurable data point that there is called the average. And that's usually abbreviated X with a little bar over it, or sometimes it'll be a little lowercase like that. And either way, those are called the average. And let's say you all taken that test and the class average is a 70. But if there's 20 of you in the room, that doesn't tell you much about your personal score. The first thing it tells you is that maybe every single one of you got a 20, or every 20 people got a 70 on the test. That's great, but that's very unlikely. If you have somebody here, and let's kind of make this like this, where make an example here, there's 70, but probably everybody did not score a 70. So let's say there's probably somebody here that scored 100. Well, if that happened, what needed to happen in order to balance out the average? If one person scored 100, 90, 80, 70, 60, 50, 40. Somebody would have had to score a 40 to make sure this average was still even. And that's for all that an average does. It takes them all up and divides by the total number, in this case 20. So what an average actually does is it tends to measure where most of the data is. And that looks something like this, where there's kind of this U shape in there. And this is called a normal distribution, where the average is right in the middle, and that's where most of the data is. Well, it turns out that this is so special that we're going to give it some other names. And rather than label this with 70 and 60 and 50, we're going to say, okay, here's my average right here. And then we're going to do something called standard deviation. And we've talked about this before, that standard deviation measures how spread out the data is. So the bigger the number, the bigger that this will get spread out. The smaller that standard deviation, the smaller that little U will be shaped. And what we're going to measure out 1, 2, 3 standard deviations each way. So rather than go, 70, 80, 90, 100, then 70 go the other way, we're going to call this standard deviation, and that will measure how spread out my data is. Well, it turns out that in a normal model, that those data points have a set pattern. And what it is that 68% of the data will be within one standard deviation. 95 will be within 2, and 99 will be within 3. So that tells you how spread out the data is. And this is normal. This is skewed normally. And it turns out that in addition to this, we could have some other distributions. And the first one will be, well, something like this, where the average is over here, and the median is over this way a little bit. And what that means is that so many people scored, whoops, got those backwards, that so many people scored down here, one or two scored so low that they actually brought the class average down compared to where most of the people were. Most of the people scored right here, but enough of you scored low down here that it actually dropped the class average. Believe it or not, that's what happens on most tests because somebody was absent, and that 0 gets factored into the class average. The other way that this can happen is when somebody scores 100, so somebody scores 100 here, when in actuality, most of the scores were lower. So, these two things, this is called skewed left, and this is skewed right. And that's what we're identifying in the first section. Draw a distribution given a couple things. When we move on, we're going to use normal distributions. Normal is the only one that we can actually use to solve anything. And we're going to use normal distributions in order to solve actual problems. So let's take a look at what we're doing in this section. We've already done this, but skewed right looks like this. And the median, oh, right here, is like so. Where there's enough people over here skewing this to the right, like so. Whoops. Yeah, definitely messed that up. Sorry, guys. Right here, I have these flipped. Always tend to do that. Like that. So right here, these are flipped. Think about what the problem's actually saying. That's how I caught my error there. That if it's skewing, it's actually pulling the mean a little bit to the right. So it's pulling this way, and it's skewing it where, so if I say the class average is 70, that, oh, great, we all passed. But it turns out a couple kids got 100 and the rest of you got 50s. That's not as good. Okay, so now skewed left. Most of you will be up here, and there's enough of us pulling this mean this way. Like so. Symmetrical will be that. The mean and the median are the same. And then we want to be able to look at this and decide which one is it. Now, we want to get used to our calculator from here on out because we're going to use this quite a bit. And we've seen how to get data into our calculator already. We're going to type all that in, and then we're going to do stat edit, or we're going to do stat edit to type it in. So let me bring up the calculator here. Oops. There we go. Stat edit. And now we're going to type this in. I'm going to type it over here so I can see. All right, so I have all my data in, and we'll go to calculate, and we just want one variable stat. So it tells me that the mean is 16.7. If I come down here, the median is 16. So 16 versus 16.7, let's write that out so we can see it. 16.77 versus 16. This was median. This was mean. So when I look at my models then, this has to be skewed right because the mean is slightly above the median. So we would just say skewed right. Now, this might be a case where you would round this and say this is symmetrical. Remember, we're dealing with actual statistics, so it's not like we're going to get anything right on the dot. So if you said this was symmetrical because this rounded, that would probably be a correct answer too. What we would look for in your answer or in the question is, did they say rounded? All right, and that's all we're doing for this first section. So you can see here, now we're looking at normal distributions. And in normal distribution, that's the one where it's always symmetrical. So it's symmetrical. The mean is right here at 0. And then for a distribution, we're always going to go up 3 standard deviations and down 3. And that's called a normal distribution. Now, we're going to start talking about percentages in a normal distribution. So, if this is normal, whoops, to the right, they want to know exactly what percent of the students scored above average. Well, it's exactly half, so this would be 50% here. If we go to the left, it would also be the same thing. Here's your normal distribution. There'd be 50% of the students scoring less than average. Okay. Now, here's those rules. Here's my average, up 1 standard deviation, down 1. 68% will be within 1 standard deviation. And we're going to go through between 2 standard deviations is 95. And within, 3 standard deviations, it's 99. And those are the numbers you want to memorize. Now, here's what this question's asking. We're going to actually get into actual problems, which you've done already. This kind of creeped in somewhere earlier. You don't have to draw this out. It is easier to have this reference. But here's me going out 3 standard deviations each way. And I want to know right here. So I want to know this probability. Well, it's not a 68, 95, 99. It's not a 50-50. So now we're going to have to actually calculate this. And we're going to use our calculator again. Our calculator is set up to actually do this for you with relative ease. We've actually already done it. We're going to go to distribution right here. So second vars, and we want normal CDF. And the numbers we type in are the mean, the standard deviation, the lower boundary, and the upper boundary. Oops. And what this, and what this should spit out is the probability that the data value is between 30 and 35. But you can see that didn't do that because it gave you a negative number. So let's just make sure I entered that in right. So mean standard deviation between 30 and 35. Yeah, it is giving me that both times. All right, let's take a look and see what's going on here. All right, well, we got our order wrong. So let's look at this again. Whoops, sorry. Distribution. It is normal CDF, but our order is wrong. Sorry about that. The order is lower, upper, mean, standard deviation. Whoops, keep doing that. There we go. So you can see I knew I was wrong because, whoops, I knew I was wrong because I got a negative value for my probability, which can't happen. You can't have a negative chance of something happening. So once I saw that, I knew I had to do something. It was just a matter of what's going on there. All right, so lower, upper, mean, standard deviation. We'll have to remember that. But there's our answer. 39% of the values will be between there. There's my probability, 39%. And you can remember we did this with probability as well. So when we do 8 here, we're going to do the same thing. And now I'm going to remember to do it correctly. So CDF. So we're going to do probability that it is greater than just 2,500. So my lower boundary is 25,000. And my upper boundary, we're just going to put a bunch of 9s for infinity because it can go on forever. The mean standard deviation. And in this case, it's a 98% chance that this will happen. So 98% probability that this will be above 2,500. Okay. So we're going to go the other way here. A 9. So CDF. And the lower in this case will be negative a bunch of 9s, comma, and the upper is 63 because I want less than 63. And this can be helpful if you're not seeing the 9s just yet. It can be helpful to actually draw this out. You don't need much. Here's your mean of 56. Here's 63, and you want everything less than that 63. So what are my boundaries? Well, it's negative a bunch of 9s all the way to 63. So that can be helpful if you're having difficulty with those intervals. Okay, let me bring that calculator back up because I forget where I was. So mean is 56. Standard deviation of 4. This should probably give me something pretty. Oh, I put minus. There you go. So 96% chance. And yeah, that should be pretty high because we're dealing with most of the values here. Okay. Now, in the last section, we're going to do the exact same thing, except now, rather than abstractly, we're going to do this with actual problems. We're going to do the same exact thing. Let's go ahead and bring up our calculator here. It's always going to be a normal CDF because we see this word normal distribution. Okay. And let's see, more than 100. So that means my interval is 100 to infinity. The mean's 90, and the standard deviation was 10. Whoops. And there's a 16% chance that a car picked at random will be traveling more than 100 miles an hour. And that's all we're doing here. You're finding specific values for these. So let's go ahead. All right, so in this one, they actually give me a boundary, 4.98 to 5.02 mean standard deviation. And this time there's a 68% chance that it'll happen. That's all we're doing here. Okay, this is another nail. I guess it just looks similar, huh? Okay, oh yeah. So the last component of this, both of these first two were probabilities. This last one's not a probability. They want an actual number, so we need to be careful here. We're going to do the same thing, distribution. All right, so my interval, 4.97 to 5.03. Mean is 5, standard deviation is 0.03. All right, so yeah, this is the same numbers as last time, so we wouldn't expect anything different. But this is not what the question asks. It says in a bag of 100 nails or 120 nails, how many? This is the probability. So you need to take that probability and times it by the total, which is 120. Notice I didn't use 120 anywhere in my problem. And there's 92 nails. The chances are the probability is 92 nails. That's how many will be. So you need to be careful here. This didn't ask for probability. It asked for actual things. Okay. And then last, the last part here, we're actually going to do a z-score. And these problems are actually a little differently worded. And we're going to kind of change the problems on the fly here. Above what percent is something a little different, which we're not going to worry about. We're going to change these problems to calculate the z-score. And you remember from the last question, or last quiz, z-score, whoops, I keep wanting to do that, was this, where it was your standard deviation, the mean, and the actual value. And what it did was it calculated the individual standard deviation of a particular value. And if your z-score was positive, that means you were better than average. And if it was low, or if it was negative, you were lower than average. And that allowed you to see how you did to your peers without actually knowing anybody else's grade. So to do all of these, I'm going to have you guys just plug those in. And this is no different than what we've done already as well. But it's good practice on the z-score. And what we'll do is we'll come back to find the percentage at a different time. So in this one, the 41500 minus 50000 divide by standard deviation. And the z-score is negative 4.25. So that means that this was below average because it was negative. Okay. So next one. This person's individual score was an 89 minus the mean divide by standard deviation. So this person's 1.9, so they were positive, which meant they were above average. Okay. 87 minus the mean divide by standard deviation, 1.1, so they were positive as well. And then here, this is actually word for word off one of your quizzes last time. So to find each person, you're going to do the exact same thing. And what I'm going to do, I'm going to kind of put this on the side so I can see it. Let's see. This time they actually, let's go. This time I actually give you the z-score. And I want you to find the salary. So this is a little different. This is worth taking a look at. Because what we're looking for is this number right here. So 1.7 is actually the z-score minus the mean over the standard deviation. And you're going to have to solve this equation for each of those. Like so. So we're going to multiply both sides by the 4,600 and then add 35,000. All right, so on the first one, whoops, typing in the wrong spot there. And this guy should be 42820. Now, when we look at Mr. Normal here, his z-score was bigger, so his salary should be bigger. So I'm going to show you guys how I'm calculating this time. I'm going to do 3.1 times 4,200 plus 35,000. And yeah, we can see that that salary is indeed bigger because it was a bigger z-score. All right, so there is normal distribution and z-scores kind of all putting together. Go ahead and practice the rest of this packet, and we'll be ready for a quiz at some point tonight. Good luck.